Kinetic theory of gases. This kinetic theory of gases was first proposed by Bernoulli, then it was developed by Maxwell, Boltzmann, Clausius and others. So the important postulates of kinetic molecular theory of gases are: first one, matter, whether it is in a gaseous state, it is made up of small tiny particles called molecules, or if it is in the case of inert gases, they may call it as an atoms. So these molecules will always be in a random motion in all directions. The matter in gaseous state is made up of or consists of a small tiny particles called molecules. These molecules are in random motion in all directions. While they are moving, they collide with each other and also make collisions with the walls of the container. These molecules are in random motion in all directions. They collide with each other and also make collisions with the walls of the container. These molecular collisions are purely elastic in nature. They neither lose energy nor gain energy due to these collisions. There is a gap, large gap between one molecule to other molecule. These molecular species are far away from each other. That's why the actual volume occupied by these molecules is negligible when compared to the total volume of the gas. For example, here you have certain number of molecules. So the volume of the gas is considered as the volume of this container. So let it be count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let it be 10 molecules. For example, saying I am taking. So if these molecules are close together, these 10 molecules will occupy this volume. This means that this is considered as actual volume of the gas, but here this is the volume of the gas. So this actual volume of the gas is negligible when compared to the volume that was occupied by this gas. This factor is said to be compressibility factor. Compression means decreasing of volume by using external pressure is said to be compression. So the compressibility for the gaseous state is maximum. We cannot compress a solid such an extent. Almost compressibility of solids almost negligible. Liquids to certain extent they can compress, but not just like these gases. So compressibility of gases is due to the large intermolecular gaps. Next, in gaseous state there will be no attractive forces or repulsive forces that exist among these gas molecules. They will not attract each other and they will not repel each other. Each gas molecule behaves independently. The presence of one gas molecule will not change its properties like pressure, volume and all these things due to the presence of another gas. Suppose for example, here you have taken certain amount of gas in 1 liter container, keeping the temperature constant and volume constant. If I introduce another gas which is non-reacting gas with this gas, the individual pressure exerted by this gas will not change due to the presence of the newly introduced gas. Of course, due to the introduction of second gas, the total pressure of the gas may increase. But the pressure that was exerted previously by this gas is the same. That means these gas molecules will behave in a similar manner when they are alone or with other gas. That means there will be no attractive or repulsive forces. That means here one condition is there, that gases must be non-reacting gases. If they react with each other, then the composition may change, and this that point will not applicable to them. For non-reacting gases only I am telling. Now, the energy of the gases is constantly changes, but average energy is constant, because they have kinetic energy. Kinetic energy means Ke. Kinetic energy is half mv square. So, the velocity of a single gas molecule is not same all the time, and all gas molecules will not have same velocities. That means each gas molecule velocity is same. If they belong to same gas, their mass may be same, but the kinetic energy of each molecule is vary. That's why we are taking average kinetic energy. Some molecules will have more kinetic energy, some molecules will have less kinetic energy. The kinetic energy of one molecule may decrease, and kinetic molecules of the another molecule may increase because of these collisions and all these things. But average kinetic energy of a given sample of gas is constant as long as temperature is constant. That means average kinetic energy of the gas molecule is directly proportional to absolute temperature. Ke is directly proportional to capital T, or Ke is equal to K into T, where K is a constant, proportionality constant. So, these are the important postulates of kinetic molecular theory.